tayo ng Math-aral. Sa Math, walang maiiwan. Math-sayang Math-aral tayo ng Math-tuto, upang ikayo masenso. Maging matyaga, maging matalino, halina Math-aral na tayo. Maging matyaga, maging matalino, halina Math-aral na tayo. Halina Math-aral na tayo. Halina Math-aral na tayo. Halina, 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 Math-aral na tayo.
And now, grade 10 students, hello! I know that you are waiting for this part. So without further ado, to discuss the grade 10 lesson, she is an organized professional with proven teaching, guidance, and leadership skills rooted from the province of Pangasinan. She is a graduate of Bachelor of Secondary Education, major in Mathematics, a cum laude from the Lyceum Northern Luzon in Pangasinan. She's been part of Isaac Lopez Integrated School since 2006 and also one of the division test writers. She is currently part of division module writer, a grade 10 advisor, and ILIS faculty club president. My dear viewers, proudly to present to you one of the greatest mathematics teachers in ILIS, Mrs. Eva Y. Almaraz.
Hello there and a pleasant day to everyone, especially to all the Batang MANDunong who are with us watching at this moment. I am Mrs. Eva Y. Almaraz and join me as we talk about week 7 of our CLAID module. For this episode, we will discuss the introductory part of this competency, focusing more on the probability of simple events. I hope that you have your pen and paper with you so you can practice solving at the same time as the discussion continues. Alright? Remember, dito sa Mandaluyong, walang maiiwan, lahat ay kabahagi sa bilang. And let us start soaring. Let us look back to some of the skills previously discussed. Let's begin with problem number 1, rolling a pair of dice. Now, if a pair of dice is rolled, A, what is the sample space? Recall that when we say sample space, it refers to the set of possible outcomes. In this event, list down all the possible pairings with your dice with the numbers 1 until 6. So you might be thinking of 1 and 1, yes, also 1 and 2, also 1 and 3, until you have listed all the possible pairs. So those are part of your sample space. Now to give you the complete list of our sample space, we have this one. Okay, I hope you're getting the same thing as what we have in our list. Now let's proceed to letter B. What is the event A that the sum of the numbers on the top faces is 8? Now look at the pairings that has been listed in our sample space. You check the pairing that will give you the sum of 8. Yes, we have the first one is 2 and 6, that is 8. Also, we have 3 and 5. We also have 4 and 4, 5 and 3, and for the last one, your 6 and 2. Let us have letter C. What is the event B that the same number is on the two faces? We know that when we talk about die, there are only 6 numbers from 1 to 6. So if we are talking about same number on the two faces, will be 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. Okay, let's have letter D. What is the event C that the numbers on top faces are both even. So remember, when we say even, we are talking to the numbers that are divisible by 2. For our die, the only even numbers that you can see are 2, 4, and 6. Therefore, the numbers on top faces are both even. We will have 2 and 2, 2 and 4, 2 and 6, 4 and 2, 4 and 4, 4 and 6, 6 and 2, 6 and 4, and your 6 and 6. Okay, let's have letter E. What is the event D that one number is 5 and the other is even? So here we have 5 and 2, 5 and 4, 5 and 6. Also, we have 2 and 5, 4 and 5, and the last one is 6 and 5. Moving on to problem number 2, deck of playing cards. One card is chosen from a deck of well-shuffled 52 cards. A. Find the number of events that the chosen card is a red card. Here we have the complete set of a playing cards. We have 4 classes, the clover or clubs, the spades, the hearts, and the diamonds. Each class has 13 pieces from ace to king. Now, if we are looking for the red card, we will consider the hearts and the diamond because these are the only red cards in our deck of cards. So, there are 13 hearts and another 13 diamonds. So, therefore, there are 26 red cards. Letter B. Find the number of events that the chosen card is an ace. How many aces are there in our cards? Yes, there are 4 aces. Okay. Next, letter C. Find the number of events that the chosen card is a king or a jack. Here, there are 4 kings and also 4 jacks. In this case, when we use the word or, it means as an alternative, as a substitute, or also as another option. So in this problem then, you will not consider only the king, only the jacks, but for both of them instead. It means both are to be counted as your choices or options. So therefore, we have 4 kings plus 4 jacks, and that will give us the answer 8. Next, letter D. Find the event that the chosen card is a queen or a red card. Here we have 4 queens and there are 26 red cards. And here, same as in letter C, we combine 4 queens and 26 red cards. But 26 red cards, your 2 queens are already counted. Now, the question is, are we going to add the 4 queens? Obviously not. What we are going to do is, we take the 26 red cards plus the remaining 2 black queens, and that gives us 26 plus 2 equals 28. Okay? Okay, letter E. Find the number of figures on the card that is divisible by 3. In our cards, the numbers divisible by 3 are 3, 6, and 9. There are 4 different cards for each. So we have 4 plus 4 plus 4 equals 12. So that means there are 12 figures in the playing cards that are divisible by 3. Okay, great job everyone. Now we move on to the next part. Okay, our objectives for today are number 1, define probability. Number 2, find the probability of simple events. Now, what is probability? Probability is a branch of mathematics that deals with the chance of an event to happen. Also, it refers to the likelihood of occurrence of an event. There are several ways in writing or expressing probability. We have number 1 in fraction form. For example, we have, I think the probability that I will pass this math test is 1/2. Also, it can be expressed in decimal form. We have the example, the chance of missing the flight is 0.65. And another way to express your probability is in percentage form. So let's see the example. We have, there is a 5% chance of not getting into the club where you want to be. Among the three, probabilities are mostly written in either percent or fraction. Why? Because it is more practical and apparent. The probability or likelihood of the event to happen is from 0 to 1. 0 means that the event is impossible to happen. Example is getting a 7 in rolling a die. So we know that your die consists of numbers from 1 to 6 and never that you will get a 7. So that is very impossible to happen. 1 means that the event is 100% to happen, or you are certain that it will happen. For example, the sun rises and sunsets, because definitely it will happen. On the other hand, 50 or 1/2 means there is an even chance that the event will happen. Just like, for example, you're flipping a coin and you would like to get a head. There are only 2 possible outcomes in a coin. So the first one is either a head or the other one is a tail. You have an even chance in getting a head. Now, the closer the event to 1, that means it is most likely the event will happen with a minimal chance that it will not happen. And also, if the event is closer to 0, it is also unlikely to happen with minimal chance that it will happen. Alright? Now, how are we going to get the probability of simple events or simply the probability of an event? When we say getting the probability of an event, that is equal to the ratio of favorable outcomes that the event will happen and the total number of possible outcomes. So in symbols, we have P of E equals N of E over N of S, wherein E is the event or the simple event and S refers to the sample space or the possible outcomes. Alright? Let us solve some examples. Number 1. What is the probability of rolling a prime number on a number cube? So when we say prime number, it is any number with the factors of 1 and itself. Now in our number cube, which is also the same with a die, we have the numbers from 1 to 6. And our prime numbers there are 2, 3, and 5. And take note that 1 is neither a composite nor prime because 1 is a special number. Now using the formula, we have your P of E equals the number of event over total number of possible outcomes. So since that our prime numbers in our number cube is equivalent to 3 and our sample space is also equivalent to 6, plugging that in our formula, we have P of prime equals your 3 over 6, or reducing that to lowest term, that is equal to 1/2. Next, let us have problem number 2. A playing card is drawn at random from a deck of 52 cards. Find the probability of drawing, letter A heart. So in our deck of cards, there are 13 hearts from ace to king. Our favorable outcome is 13 and with our sample space is 52. So using the formula, we have your P of E equals your N of E over your N of S. P of a heart, that is equal to 13 over 52, or reducing to lowest terms, that will be equivalent to 1/4. Letter B, find the probability of drawing a red card. There are 13 hearts and another 13 diamonds, so that is equivalent to 26. P of E equals your N of E over your N of S. So we have your 26 over 52, and getting the lowest term, we have 1/2. Next, we have letter C, finding the probability of drawing a king. So in our deck of cards, there are 4 kings. Using the formula, we have P of E equals your N of E over N of S. Plugging in our given, our event is getting a king, so we have P of a king equals your number of kings. We have 4 over the number of sample space, we have 52. Reducing that to lowest terms, we have 1 over 13. Letter D, getting the probability of drawing a black ace. In our cards, we have 4 aces, we have 2 black and 2 red. Our event is black ace. Using the formula, we have P of E equals your N of E over your N of S. P of a black ace equals your 2 over 52 or 1 over 26. Now let us have problem number 3. 3 coins are tossed. Find the probability of getting exactly 2 heads. In this case, before we give the answer, let us list down all the possible outcomes. First, when you toss your 3 coins at once, you have the possible outcomes. So first, it can be all tails. Next can be tail, tail, head. Another is also your tail, head, tail. We also have head, tail, tail. Another is head, tail, head. We also have tail, head, head. And another can be head, head, tail. And for the last one is your all heads. Now, based from here, how many times that your exactly 2 heads appear? We have your head, tail, head. We also have head, head, tail, and your tail, head, head. So there are 3 chances that the event will come out. Now, how many possible outcomes are there? There are 8 possible outcomes. Looking at the formula, we have P of E equals your N of E over your N of S. And our event there is getting exactly 2 heads. So we have P of getting exactly 2 heads. And since our event there is equal to 3 with the possible outcomes 8, therefore the final answer here will be 3 over 8. Let us have number 4. A red die and a blue die are rolled. Find the probability of the following event. Letter A. A equals the blue die shows 6. Here we have 6 chances that the event will come out. We have 1 and 6, 2 and 6, 3 and 6, 4 and 6, 5 and 6, and 6 and 6. And regardless which one will be enumerated first, either the red one or the blue one, for as long as you have the blue die showing 6. Still, there are 6 chances that the condition be met. How about the sample space? Since that we have 2 dice, the sample space here will be 36. Now, if we are going to get the probability of the event A, P of A is equal to 6 over 36 or 1 over 6. Next, let us have letter B. Event B is equal to the sum of 2 numbers is 8. So in this case, we know that we have 6 and 2, that is 8, yes. Also, we have 5 and 3, 4 and 4, 3 and 5, and 2 and 6. So the probability of B is equal to 5 over 36. Letter C. C equals the sum of 2 numbers is less than 6. Here you try to check out the pairings in our sample space that will give you the sum of less than 6. Okay, so in this case, we have 1 and 1. We also have 2 and 1. Also 3 and 1, 4 and 1. We also have 1 and 2, 2 and 2, 3 and 2, 1 and 3, 2 and 3, and 1 and 4. So if you check the chances that you will have the sum of less than 6, there are 10 chances out of the 36 sample space. So it means the probability of C is equal to 10 over 36 or 5 over 18. Now moving on to our last example, we have number 5. A couple plans to have 3 children. What is the probability that all children will be girls? Okay, so in this particular given, we assume that it is equally likely to have a boy or girl. Listing down the gender of the children, we follow from the first, second, and third. And now we might have the chances of first, we have boy, boy, girl. Also, we have boy, girl, girl. Can also be all boys. Another is boy, girl, boy. Can be girl, girl, boy. All girls. Girl, boy, girl. And finally, it can also be girl, boy, boy. Looking at this, there is only one possibility that the event of all 3 girls will happen. We follow the formula once again. We have P of E is equal to your N of E over N of S. Therefore, we have P of all girls is equal to 1 over 8. Before we finally end this session, I want to share some thoughts. Always remember that the probability of learning and understanding mathematics is neither impossible nor an even chance, but certain. Just believe in yourself and keep watching the Project SOAR. Okay, once again, this is Mrs. Eva Y. Almaraz, and thank you for watching. Goodbye!